In Chapter 8, we are going to be dealing with a lot of problems that have variables in the denominators. And the beginning to that is inverse variation. Inverse variation talks about as one quantity goes up, another quantity goes down. And we'll see that played out in a lot of things. Like, for example, if you buy something at Costco, like, for example, the more you buy, the less it is per item. So that's why, like, people like say buy in bulk. That is actually an example of inverse variation. Before we start, I do want to talk about the difference between direct variation and inverse variation. Now, direct variation you did learn in Chapter 2 in Algebra 2, but you also learned about it in Chapter 5 of Algebra 1. Direct variation is described as a relationship in which both variables increase or decrease. So both of them, they increase or they both decrease at the same time. So direct means they're both doing the same thing. As one goes up, the other would go up as well. And the opposite is true. As one goes down, the other one would go down. The equation, which we learned in Chapter 2, is y equals kx. Oops. It's literally like, it's just like y equals mx plus b with no b. It has a point of 0, 0 on it. For example, let's say you go out and you buy a bag of oranges. So the more oranges you buy, I don't know why I'm picking oranges, but the more oranges you buy, the more it's going to cost you when you go to the register. Okay? Inverse variation. Inverse variation is used to describe the relationships in which, as one goes up, the other one goes down, and vice versa. So the equation is still y equals, and it's still actually y equals k, but this time it's not k times x, it's k divided by x. Maybe a good example would be the more time you spend on your quad, the less time you have, and yeah, I am speaking to some of you in particular, the less time you have for your homework. Look at that. That's an inverse variation problem. In both cases, k has a title, and it's called the constant of variation. That is a huge deal because on the test it will say, what's the constant of variation? And you have to know that means, what is k? There are steps to take in each of these problems. You need to decide, first of all, whether it's direct variation or whether it's inverse variation. So are they both going up, or is one going up and one's going down? You're going to determine the two things, put them in for x and y. You're going to plug in the information and solve for k. You're going to make a new equation. Make sure you fill k in. For example, it will look like y equals 3x, or it will look like y equals 3 over x. So you're going to fill in k. And then they'll ask you more to plug in, and you have to solve for the unknown. Part 1 of the notes, we are going to be given a table. A table of numbers, and we need to see if it's direct or inverse. So, in order to test for direct, you are going to do, I know it sounds odd, you're going to test y divided by x. And if every y divided by every x is the same, it is direct. So it would fit this equation, y equals kx. On the other hand, if that doesn't work, you're going to test for inverse. So you're going to do y times x is the test. And if it's the same each time, it is inverse, meaning it would fit the equation y equals k over x. And if it's not the same each and every time, so if it's not the same each time for y divided by x or y times x, it's neither. It's not direct nor inverse. We have 5 problems to check out. Now what I'm noticing about these x's, 2 to 10, or excuse me, 2, 4, these are going up and these are going, let's see, down, 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 down in their absolute quantity. That means I'm going to test for inverse. Remember, inverse is one goes up, the other goes down. So the test for inverse up here is y times x. So each of these y's times each of these x's. Well, let's see. That's going to be 15 times 2, 7.5 times 4, I'm going to use parentheses, 3 times 10, 2 times 15, and yeah, each and every time you did this, if you put those in your calculator, each and every time you would get 30 when you multiply. Because it's the same each time, you have found the value of k. And not only have you found the value of k, you know that it's inverse because it's the same. So we write y equals, because it does ask us for, it says what function models, the directions, what function models this? The equation is y equals 30 over x, and it is inverse. Part B. Look at your x's. Can you see how your x's are again increasing? I'm noticing it goes 2, 4, 10, 15, so those are going up. But I do notice that the y values are getting lower. Well, that kind of tells me I'm going to try inverse again. If that is the case, we're going to try multiplying them together. So I'll do y times x to test for inverse. So I do 10 times 2. Well, that's 10 times 2. That gives me 20. And I'll do 8 times 4. That gives me 32. I can stop. Those are not the same. Really quick, let's go ahead and check direct. I highly doubt it is direct because of the arrows, but we may as well try. So we'll take all the y's. So you're going to do y divided by x. So I'll take 10 and I'll divide by 2. Okay, that's 5. And I'll do 8 divided by 4. Okay, that's 2. Those don't match. This is neither. Let's check out A, B, and C down below. I'm going to try to identify a pattern. So I'm noticing that these x's are going up in quantity and those y's are going up in quantity. So I'm going to try for direct because the arrows match. So that means I have to do y divided by x each time. So I'll do 8 divided by 0.2, 20 divided by 0.5, 40 divided by 1, 60 divided by 1.5. Let's see what we get each time. 8 divided by 0.2 makes 40. 20 divided by 0.5 makes 40. 40 divided by 1 makes 40. 60 divided by 1.5 makes 40. Those are all the same. Since they all match, I know I have found that this is truly a direct problem. So it's going to be y equals, and you just have to look up here, the equation is y equals kx for direct. So I found my k value to be 40, because that's what we got over here, x. Let's try part B. I'm noticing that my x's again are increasing in value, and that my y's are decreasing in value. I'm going to test for inverse. So inverse is going to take all the y's, like 40, and multiply them by their x's. So again, the y, 16 times the x. Again, the y of 8 times the x. Again, the y of 4 times the x. And we're going to see if we get the same thing every single time. Well, I can tell you 4 times 2 is 8. I can tell you these 3 are 8. Chances are 40 is going to be 8 too. Let's check it out. 40 times 0.2, yep, that's 8. Because they all match, it is truly an inverse problem. I'm trying to stay out of your way here. Let's see. So down here I'll write inverse. Because it's inverse, it's y equals a fraction. 8 goes on top, x goes on bottom. So there's the model and there's the inverse. Part C, we'll check out and see what they've got. I am noticing that the x's are going consistently up in value and that the y's are going down in value. That means this is going to have to be an inverse if it's anything. So let's test the test for inverse way up above. The test for inverse is y times x. So I'm going to do 40 times 0.5. I can do that one in my head. That's going to be 20. I'm going to do 12 times 1.2. I'm going to do 10 times 2. That's 20. I'm going to do 6 times 2.5. And let's just check a couple of these. I don't think 6.25 is right. 6 times 2.5 is 15, which does not match the other ones. Let's see what 12 times 1.2 is. 14.4. Those do not match. This cannot be inverse. And if you wanted to test for direct, you would take all these y's, like 40, and divide by the x's. But you can see that when we do that, we don't get the same thing consistently either. So this is a neither problem. Okay, no equation then. Moving on to part 2 of the lesson, you need to learn how to graph inverse variation. The graphs will always be like kind of opposite. They look like this. They're either going to be here and here, or they'll be, I'll do it in a different color, here and here. They're as opposite from a straight line as you could possibly get. They're 2 different graphs, and they're like weird looking curves. Suppose x and y vary inversely. X is 4, y is 3. Part A. What function models the inverse variation? All right, so make an equation by putting x and y and solving for k. So inverse is this equation. You do need to start with that. That is the inverse equation. You got to have a place to start. So they're telling me that x is 4 and that y is 3. So I can do 3 equals k over 4. And then the directions say solve for k. So I need to multiply by 4 on both sides. 4 times 3 is 12. These 4's cancel out. 12 equals k. Part 2. Rewrite the model with k filled in. So y equals the value of k, 12, over x. That's your model or your equation. Same thing. Now we're going to graph it. What does it look like? So make an XY chart. Because I have the number 12 here, by the way, you need to put in negatives. You need to put in negatives. You need to try to put in 0 and positives. I'm going to be a little bit lazy, and I'm going to pick things that go into 12. Just makes it easier that way. That's what I mean by pick factors of k. So I'm going to pick negative 12, negative 6, negative 4, negative 3, negative 2, negative 1. I will pick 0. And then I'm going to pick all of those as positives again. So I'll pick 1, 2, 3. I guess I need a bigger XY chart, don't I? 4. I'm not going to pick 5, but I'll pick 6 and I'll pick 12. I'll pick numbers that go into 12. And now we just need to plug them in. You are literally just going to plug them in for that x. I'm trying to move my calculator so you can see it, but still see the x. So plug those in for that x. So we'll do 12 divided by negative 12 is negative 1. 12 divided by negative 6. You can probably do this faster if you just try it in your head. 12 divided by negative 4 is negative 3. Look where I'm pointing at. This is where I'm plugging into. 12 divided by negative 3 is negative 4. So I'm just plugging it in. 12 divided by negative 2 is negative 6. 12 divided by negative 1 is negative 12. 12 divided by 0 comes up with an error because you cannot. So we call that undefined. Can't divide by 0. Now, 12 divided by positive 1 is 12. 12 divided by positive 2 is 6. 12 divided by positive 3 is 4. 12 divided by positive 4 is 3. 12 divided by positive 6 is 2. 12 divided by positive 12 is 1. Those points are going to give me a perfect looking graph whenever I go to it. So I'm going to go negative 12, negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which would be right there. Now, I am going to cut out the video and plot the rest of my points, and I want you to do the same thing. Pause the video.